So in this session, my plan is to discuss classification algorithms up to comparing multiple classifiers. So with that said, let's get the dataset from the LMS. I have uploaded the dataset called Pima Indians Diabetes data.csv. Can you please download it? Let me give you the code for uploading the dataset. Right? Remember, in this code, actually, we are going to upload to the local machine, right? So when you run it, you'll get a button. Right now, I have downloaded the dataset, and it's in the download folder. I'm going to go to downloads, and I'm going to click on the dataset. Okay, so here is I have uploaded, and if it is a success, you will see that this should be available in your local machine. Right now, you can notice that it's in the local environment, Colab. Okay, let's now view what is inside in the dataset. So I'm going to use pandas data frames. And then this is a CSV file. You can see the file name here. It says Pima Indians Diabetes data.csv. So that's the file name. So the command is I'm going to say it's a data frame df. I will say pd.read underscore CSV and data.csv. Right. And then let me type, get in the first file record also. Right. So it looks like this. So originally we didn't say our head here. So therefore, let's put up some label for each of these columns. Right. So I'm going to include that as names. Let me put value for each of these columns. And then I'm going to provide it here, those names. Right. So hopefully now it's okay. Yes, we are getting the first 5 records. Right. Now you can observe the dataset. Please go through the dataset and see whether you can understand what is available in the dataset. So when you say head, it will just show you what is inside. If you want, you can see how many records do you have. So this is def.head will give you the first 5 rows. If you need 10, you can put 10 inside. You will get the first 10 records. Or if you put tail, you might get last 5 records and so on. Right. Now that we have viewed, we can move to the next part. As a first step, usually you can look at how many rows you have, how many attributes you might have. So that information you can check. So for that, I'm going to say df.shape will give you the number of rows and columns. It says 768, 9. So that means you have 9 attributes and then you have 768 records. Right. So we got the data set. I have uploaded it in the LMS, and then we use pandas to create a data frame based on the data set. So headers were not provided, so I have separately put the headers. And then now I know that we have 768 records with 9 attributes. Okay, next step. We can also look at the data types. We say D types. The idea is before we do any analysis, it's better we know like what kind of a data we have. So you can see the first 5 records is the integer data type. 6 and 7, we have float. You have decimal points, and then 8 and 9, you have again integer values. So although I actually put this short, so the first is about the number of times pregnant. You can actually search about the data set. Second one is about like glucose. It says plasma glucose, about a test. It says glucose tolerant test. So that's what you see here. Third one is actually a blood pressure. Fourth one is about the skin thickness. Then insulin tests, BMI. Then you have diabetes pedigree as a floating point number. Age in years, and then the outcome, right? So this is the class variable, and you see you have 0 and 1s. Right. So let's see, now that we have just understood this one and what needs to be done, you can see it's a classification problem. We have to predict the class value. So ideally, we know the very first step is you can look for the basic statistics because it's a numerical data set. So let me start by looking at the statistics. You can simply say df describe. Right. So you can notice that the values given for you. So I told you like the first column is about the number of times the pregnant. If you look at the minimum is 0, maximum is 17. Second one, the glucose, plasma glucose levels. And if you look at the values, the minimum is 0 and max is 199. The values are between 0 to 199. Blood pressure going from 0 to 122. Then we have skin thickness. If you are looking the values, it goes from 0 to 99 in millimeters actually. Then we have insulin. We have 0 min and max is 846. Then BMI values goes from 0 to 67.1. You can notice that BMI is given as a floating point value. Diabetes pedigree function, if you look at the minimum, 0.078, and it goes to 2.42. If you look at the patient's age, going from 21 years to 81 years, and outcome we know it's between 0 and 1. Right, and it's given you the quartile values as well, 25%, 50%, 75%. You can see the schooners, you can look for it, right? Ideally, the next step would be like we can look for the details. Right, now, this is okay, but a slight modification of this one in case if you want to so this is going beyond the width of this in my case at least. So if you want to fix into the window size, you can actually make some changes. So for example, we can say pd.set option. Ideally what we are going to do, actually we are going to control the display width. So I will say display.width, and then I'm going to say it's 100%. That's one thing that I can control. Same time, I can also like the number of decimal places is huge. I mean, there's no point of taking that many. So we can control that one as well. So for example, this is called precision. I'm going to make it to 3 decimal places. And now once you set this option, and if you type the same thing again, describe, this time you will see it's slightly modified and easy to read as well. So you can notice same thing. I'm going to share the code in the chat. Right. So for the attribute, if you are seeing numbers, Gayan, its reason is I have set the names. I think you might have not set the names. Can you check, Gayan?
Yes, I'm checking that. That's the reason, I think.
So anyway, I have shared that again in the chat. Right. Okay. Right. Now let me look at histograms. Um, and for that, we can use histogram. So I'm going to make a plot. So we know that we have to use matplotlib.pyplot as PLT. I'm going to use hist, which will give you like histogram of all the attributes. So you can run and we are getting an outcome like this. Slight adjustment. So you can notice that it's not that very clear. So a couple of things I'm going to do. First of all, I'm going to adjust the spacing. So most of the time, if you notice this command type layout, which will adjust the spacing, will make it more clear. And finally, we will use show so that now you can observe the histogram as proper, right? So have a look at the data distribution. We have not we have seen this in earlier with the statistics, distributed statistics, but then visualization is one point that where you can see many of the things with the data is skewed to one direction, or whether the data is actually normally distributed and so on, right? So you can notice that you should see output very similar to this one, right? So make a notice like the data distributions. So as the next step, actually, what I'm going to do based on the class values, I would like to redraw this graph. I'm not going to do for everything. I'm going to select one particular attribute. So let me select the second one. And I'm trying to visualize how this data, this is common for both the classes, the class distribution. So why it is important, if you remember in the theory we discussed, when you are selecting attributes for decision tree root node, so looking at the pure separation is very, very important, right? So we are like, for example, if you are using information gain, the visualization will give you some indication like what attribute is best put in the root node, right? So for that purpose, I'm going to actually have a look at how we can do this. Right. So now what I'm going to do, I'm going to select the based on the class, right? So this is what I'm going to use. So we know that in the class, let me take the code. For example, if you get your data frame and if you group by based on the class, and then if you say size, you can see the number of classes. So we know we have 500 with class label 0. We have 268 with class 1, right? So this is basically the distribution. Right now, what I'm going to do is I'm going to plot for the second one, right? And what I'm going to do is, based on the class label, that I'm going to make a, outcome, right? So the idea is we are going to separate the data sets based on this class label. So the idea is, it's something like this. What I'm trying to do is I'm going to get the class based on the class label. So class label means I can say df, I can say class. Remember fancy indexing idea that we have discussed? That's exactly what I'm going to do. So if you put like, let's say 0, right? That you can actually get the data where the class is just 0, right? And if you need a histogram, you can just say hist should work, right? Based on the class 1, right? Just the class 0, right? So that's one way that you can actually separate the data set. And that what I'm going to do is I'm going to do this for both the classes. I'm going to separate the class and then I'm going to draw the histogram, right? So the idea is, for example, I can say this is a subset. And then what I can do is I can say subset dot hist will give you, the same thing, right? But then again, I have to do this for both the classes. So what I'm going to do, I'm going to make it automate, like instead of putting 0 and 1. So I'm going to update this for all the classes we have. So I'm going to say classes. I'm going to automatically use this code class. And then I'm going to say unique. So ideally what happens, I will get 0 and 1, right? Okay. And the next one is, right? I'm going to go for each of the class. I'm going to say class label in classes, right? What I'm going to do is I'm going to make in subsets. What is the subset? Instead of putting 0, I'm going to say, okay, I'm going to check this for the class label. So ideally, in this case, it will run for twice, right? And then I'm going to plot the histogram. So I will say, I'm going to say pld.hist. And then here I will say subset. And just I'm going to select just one. The second one I'm going to select. So I will put this one so that I will get just one, right? So let me see. Yes. You can notice that we have just select just one attribute, right? And then we have draw for everything. Right. We can remove this and see. Yeah. So then we will just for the second one. Okay. Right. Another thing that I want to update here is like I want to see the distribution of the two classes. So therefore, what I can do is I can set the alpha level. So maybe one thing I can say, the transparency I can set. Let me put 0.7. Okay, now you can see both the classes. So this will be helpful for you to see how the two classes are, distributed. And one more thing is you can add some titles. So let me update slightly the code. Few things that I can add is I can put the title. So let me say, I'm going to say plt.title. Okay, plus distribution. Within what was our, this is the second one. It goes plasma glucose concentration. We'll say plasma glucose concentration. Okay, so I put the whole name so that you know. Okay, so that's the first thing that I have done. So let's label. So I'm going to put glucose concentration and frequency. Okay, classes and okay, it's automatically comes in. Let's see with okay, this is okay, right? So we got the classes, frequency. Okay, that's automated, right? And finally, okay, show as well. Right, let me give you the code for you. So this part particularly I discussed because this part is very useful to understand how the classes are distributed. Right. Right. So I'm going to use a box plot to identify any outliers or view as a box plot. You can notice that it comes like this. Maybe I can put in the layout size. Maybe I will change here layout information. I will put since we have 9, we can easily put 3 by 3. So I put layout information, right, which draws like this, okay. And maybe we can use plt.show. Okay, if you have the problem with the spaces, I always told you, like, it might be worthwhile to try. Okay, hopefully this time it will, okay, it's much better now. So you can observe the box plot, the average, as well as you can also notice that whereas some are not within the range, or maybe you can consider them as outliers. So that information is given here. Right. This is visualization. I think, one more visualization I want to discuss, that is correlation. With that, we can actually focus on classification. Right. Now that we have learned to visualize this one, right? Next point that I would like to see, now we are going to make classification problem. And another thing that we are interested to see what correlation are present in the data. For example, when you increase one variable, whether increases with the class, whether there's a positive correlation or whether there's any negative correlation with the data. So correlation matrix can be easily, you can get it with simple, single command. For example, I can say df correlation, and we can provide what method you are going to use. So let me say method is Pearson. We specify Pearson correlation here, which you will get a table like this, and you can notice how each of these attributes are correlated each other. But particularly you want to see the correlation together with the class attribute, right? Focus on the values given in the class attribute. And if you look at the correlation values, everything is positively correlated to get towards the class, and the highest correlation goes with the second one, right? So that is the reason why actually I have actually showed you the that particular attribute, because it's highly correlated with the class, which indicates that that is the one of the attribute that you might have to choose, right? But always graphical representation is better. So for that, I will give you a code directly to you where we can draw this one. Right. There was a question in the chat about explaining the box plot. I hope you remember the statistics that we have seen about each of these numerical data, right? So if you start with the box, right? So the first one is number of pregnancies, right? Can you see the number of pregnancies here? If you compare the values together with this one, you will understand, right? So the box will actually represent the values between the first quartile, right? That means 25%. And then third quartile. So that means you have 1 and 6 for the first one, and the mean is about 4, right? So it's between 1 and 6, and it's about 4 here, the average value. Right? And then the dots that here, the circles, I use the term outliers. They are not within the range, right? Usually these are known as whiskers. That means going from minimum and maximum within, usually there's a calculation for this one, calculate on this, and then they say lower whisker and upper whisker and so on. So the values are not within the range, it will represent as circles. And those are called outliers, not within the default range, right? You can actually ignore them in some analysis, right? In this particular case, I'm not planning to remove, but you can think of removing that if you have enough data points and if you are not going to consider them. They are very infrequent and not within the range of the values, right? This is called unusual value. Now, for example, let me give an example of salaries. Commonly, like generally in the employees, there's a range of salaries. But for example, if you take CEO or the company owner get very high salary, which could be considered as an outlier, right? So that's the box plot represents. So ideally, you can get an idea about how the data is spread within the data. Another view of histogram, but ideally it will indicate also about the value outside with what we call the quartile range. We call interquartile, right? I told you this is the middle one, and then this is the 25th% of the quartile, the first quartile, and then this is the third quartile. So that's what we normally use, right? So usually this one represents the around 50% of the data, right? Within the box itself. I told you like it's first quartile and the third quartile. So between that, it's 50% of the data, and then that's how the range normally be defined. Okay. Now, with that said, I'm going to move on to the next part. So within the next one, now that we have done, let me show you the correlation plot as well. So I'm going to give you directly the code for this one in the chat, so you can just copy paste it. So what we do here is we are going to graphically represent our correlation values. Right now, I told you already by going through the values, the second attribute is actually highly correlate the class. So I'm going to copy paste the code, and we will get an outcome like this. Let me take this into a new tab. Right. So this is graphically shows you the correlations, and red color represent the positive correlation and the blue color represent negative correlations. And you can see that majority of the times you can see positive correlations. And especially if I focus on the class, because I'm interested, this is a classification problem. So if I look at here, you can see that, okay, the second attribute the glucose plasma test. So that's the highly correlated with the class attribute. Done? Finish up to this point? So let me start with the decision tree model building. So that code is already you have, but we have the data frame, right? So if I just view my data frame again, we have 9 attributes. That means the last one is the class. So I have to separate first the data with the class. So I can say X, DF, I'm going to separate based on the index values. And I'm going to use all the columns except the last one. That's my X. Y, I'm going to select the last one. So if you double check, you can check X head. Yes, you can notice this one. Or you can use Y just to check. Okay, so that's okay, right? So now I first separate my data as X and Y. So that's the first thing I'm going to do. Then I hope you remember that we will separate the train and test data for the modeling aspect. So for that, what I'm going to do is I'm going to use scikit-learn.model selection. And I'm going to import train test split. And what we do is we will separate the train Y train, Y test. So the idea is we will use train test split, and I will provide X and Y. Okay, test set size. Again, this is something that you need to select. I prefer 2/3, and there's no universal, agreed value. So you can decide on which one you are going to use. Apart from that, I'm going to use random state as well so that we all get the same accuracy. Otherwise, we might get different accuracies. So to control the randomness, I will say, I will choose random state as 1. Actually, you can use any value here. The idea is we have a control of separating training and testing. Right. Now that we have built this one, the data is separated, train and test. We can now select the tree structure. We know that we have to use sklearn. We are going to use tree. So I'm going to select the classifier as decision tree. Then we'll train the model. For that, I'm going to use training data. I use X train and Y train. Now that we have built the model, we are going to evaluate. So we will use our test data set. So now we have predictions, right? And the next one is we need to look for the accuracy low. I'm going to use matrix. I'm going to import accuracy score. So ideally, this is what I'm going to use. So now I have predictions. I have, values. So simply I can say print accuracy score. I'm using the actual values, the y-test with predictions. Right. That's about the decision tree accuracy. So in my case, if you look at with this one, I'm going to get about like 70% accuracy, 0.72 something. Okay, there was a question on use of random state here. So let me remove this and show you. Now, random state will actually give you control on how to separate train and test. Because, when you ask to separate data into two pieces, there are many ways to do. It's random, right? So if I just remove the random state, and then if I rerun, you will notice I will get different accuracies in different times. It is because whenever we run, we split, we get different splits, right? Now to control over this one, if everybody wants to get the same answer, now for example, I'm giving you a code and you want to check whether you got the correct answer. So that means you have to have a control over the randomness, right? So that's why I put random state. So when I say random state one, it's unique. So if you use random state one, and if I use random state one, when you run it, it's random, but it's called pseudo random. You will get same accuracy every time. Okay, did I make a mistake here? Okay, so classify also we have to specify. Sorry about that. This one we control here. At the same time, classify also we have to put the randomness. Okay, let me put the randomness there. So we can say random. Is it random states? Oh yes, state. Otherwise, there's a randomness there as well. So let me put one here as well. So hopefully, yes. Are we getting? Yeah, we are getting the same accuracy now. Okay. I think it's a good point that you have asked that. So now you can see I'm controlling the random state here. That means dividing the data set as train and test at the same time in the decision tree as well. So now you can notice that I'm actually getting the same accuracy. Are you getting the same accuracy? Okay, I think in this one, what I have showed you is, model building process where we separate the data as training and testing and use the trained data to build the model and evaluate based on the test. So that's the traditionally what we used to do. But this is okay for large data set. But if you have small to medium data set, usually this is not preferred method because you have a limited data. And you know that when you change the number of, data is limited, you have to maximally use it. So therefore, if you want to minimize the variance that you will get by dividing the data. Now you can notice that we use randomness to control it, but every time when you run it, you get different accuracy. So if you have to consider that variance into account, there's another evaluation strategy which is commonly used. It's called tenfold cross validation. The idea is you separate the data into 10 pieces. That's why it's called tenfolds. And you take one fold out as a test set and take the remaining as training data, and you repeat this for 10 times and you take the average. And this is commonly used technique, especially when you want to compare multiple classifiers. You can use it tenfold cross validation as an evaluation strategy, right? Again, but you have to be very careful. If you try to apply this to very large data sets, it takes time, right? So therefore, for very large data set, maybe this is what we need to use. You separate the data as training and testing. Okay, so let me explain. And theory, I will discuss how exactly this happens. So I want to discuss what we call tenfold cross-validation. Right. So what happens here, I'm going to develop 10 trees and then, going to calculate the tenfold accuracies. So for that, I have to get model selection. And let's see, I'm going to use tree. Right. So first of all, you have to create folds. Let me say this is as k-fold, and we will use the method k-fold, and we have to specify number of splits. I'm going to use 10. It's common one, but some people use 5 folds, 3 fold. I mean, depend on your requirement, you can use. Then you have to say random state again. To control the randomness, let me put 1. And you can also say shuffle. Right. And that's all. Then we can create the classifier. I'm going to use tree dot decision tree classifier. You can use random state here as well if you want to get the same accuracies, just to compare. Now this will run for 10 times since we have put 10 here. So therefore, can you see now? Right. Sorry about that. And then we will calculate the results. We use cross-value score method to get the classifier. And then we'll specify number of folds as k-fold. Right. And then finally, we can print results. Right. Let me run this. So you can notice that we are getting 10 accuracies here because we are separating data into 10 folds. So you can control here how many folds actually you want to have it. And 10 is common one. Of course, if you need to improve, So this is everything you have, right? Maybe I can average out and show you the answer. So therefore, maybe I can say print f. Let me write f string. I'm going to say accuracy. Accuracy is you have to get the results dot mean, which will give you the accuracy. Yes, but let's put this in a proper format. Like what I need is something like 70%. So if that is the case, I have to format this one. So I have to multiply by, let's say, 100. And let's say I want to limit it to 2 decimal places. So you will notice that one. And then let's say I want to have a percentage symbol. I can put it here, percentage symbol. Right. So accuracy 70%. Okay, next. Let's put the standard deviation as well within the brackets. So what we can do is we can say, okay, results dot standard deviation. So you will get something like this within bracket. Again, if you want to same format, you can multiply by 100 and then limit to 2 decimal places and put the percentage symbol. So, I mean, in this way, you can notice that the average accuracy we have received with the 10-fold cross validation is about like 70% with the 5% standard deviation. Right. The next one, let's see how we can work with other classifiers. So instead of pre, so let me use nearest neighbor. So the idea is you have to replace this with the nearest neighbor classifier. We have to use neighbors, import nearest neighbor classifier. And then the other place that you have to do is, this is the place that you have to change now. So the change is we have to use nearest neighbor classifier. So we can say k neighbors classifier. And then if you run it, you will get an accuracy. So you will get 0.76, right, as the accuracy. But ideally, I would like to perform 10-fold cross validation and see the accuracy values. So let me put into several models into one, and then we'll evaluate model in a loop, and then we'll make a simple graph. So that's what I'm going to explain next. Right. So let me share this first. Similar to that, I think we discussed about the naive Bayes as well. If you want to do it for the naive Bayes, in naive Bayes, okay, under this one, we can go for naive Bayes. Right. And usually we use Gaussian naive Bayes. I think I have explained Gaussian naive Bayes. Calculating probabilities for categorical data is okay. For Gaussian naive Bayes, we are using Gaussian function. The likelihood actually we are calculating, and those likelihood values can be used as a probability value. So that's what happened. And what we have to use is the Gaussian naive Bayes, and then we have to use Gaussian naive Bayes. So if you can use this one. So let me update that for the naive Bayes. So the command that I'm going to change here will be scikit-learn. We will say naive Bayes, and we import Gaussian naive Bayes, right? And here I will say naive Bayes. Okay. Right, I think that's all. If I run this, you will get 0.75. Okay, so now it's up to you. Although we have not discussed the theory for all the classifiers, any of these classifiers you can choose under this and put it here. For example, let me see where is the support vector machine. Okay, we have support vector machines, right? And then you can use SVC. It's called support vector machine. We can use sklearn dot support vector machine support vector classifier, right? And then we can use support vector machine. Right, so let me use the 4 classifiers and then let's compare the 4 classifiers, okay? So I hope you got the idea. Now let me start that part. I'm going to compare, right? The idea is I'm going to compare, machine learning algorithms. Right. Now, first of all, let's put down what classifiers we are going to use. I'm going to use scikit-learn. I'm going to use import trees, or you can simply say scikit-learn dot tree. I think that we could have done earlier as well. Import decision tree classifier. Okay. Yep. So that is the first one. Then let's use nearest neighbor. We can use sklearn neighbors. Import k nearest neighbor. Then okay, I think all these we need. Right. So we'll use Gaussian. One more thing. Let's use support vector machine as well. Right. So we are using decision tree classifier, k nearest neighbor, Gaussian. Okay, one more thing. Support vector classifier also will include. We'll use sklearn.svc import svc. Okay, I think 4 classifiers is enough. Other than that, what we need to separate data. Okay, we can have model selection cross validation score that we need it. And also, do you need accuracy scores? We don't need, right? So I'm going to remove this one. This should be SVM. There's an error, right? Okay. So now we have done this. Right. We have get everything. I'm going to have a set of models as a list of models. So I'm going to use models. And then I'm going to have results, right? And then also the names. I will explain what this is. Now, because I want to get the results together with the names. So when I put the models, I'm going to use a format like this, models. append whatever the name I just want to use here. So for example, I can use decision tree. I will put DT. And then I'm going to use decision tree classifier, right? Like this. Similar to that, then I can use append. We'll use KNN to say that it's K nearest neighbor. And then I'm going to use K nearest neighbor classifier. Then I'm going to use Naive, the name. I'm using Gaussian Naive that I have selected, and models.append we'll use support vector machine. The method is we use support vector classifier, right? So those are the models that I'm going to use. Right. Now I'm going to get models in a loop. So I'm going to get name and a model in models. So what happens here? For example, the decision tree will come to the name, and this will be the model. And then I'm going to, compare it. So I'm going to use cross-validation. So I'm going to say k-fold, and then I'm going to say k-fold n splits 10. And I will specify some random states to make a control over the randomness. I will set shuffle to true. Right. And then we'll get the cross-validation results. I'm going to say CV results. We'll use cross-validation score. And for that, I'm going to use model, provide X and Y data, and cross-validation is k-fold. And scoring, we have to decide. I'm going to select the accuracy. Right. So what happens? We are going to, get the results for this one. Now, this will happen for, this should happen for every model that we select. So therefore, we have to append them into list of accuracy. So I'm going to say lists results dot append CV results, right? And remember that this CV results is a list of accuracies because we are performing for 10 folds. And the names, I'm going to append name in another. So I have two lists, where in one list I have results, the other one I have names. Right, now let's make a print. Right, so what are we going to print? First of all, a name. That means it will tell me whether it's a decision tree, nearest neighbor, and so on. Then we need to show the mean. So let's calculate CV results dot mean, right? And then that's the mean value. And then let's put inside the bracket, I will put CV results dot standard deviation. Right. So let's run this. Hope everything is okay. So if I run this, okay, there is a problem here. Append. Okay, it should, okay, my model has names, right? It should be names dot append name. And then when you print it, it should be name. Okay, so that was the error. Right, you can notice that we are getting this one. So if you want to format it the way we have done in previous, we can update this one. Maybe I can multiply 100 and then limit to 2 decimal place with the percentage symbol. Similar to this one, we'll multiply by 100 and limit to 2 decimal places with the percentage symbol. So now this time, okay, so I'm getting the accuracies like this. Right. I think now I can share the code with you. So what we have done is we have selected several machine learning algorithms, and then we have discussed performing tenfold cross validation for each of these models that we have selected, and then print the outcome. So right now, if you look at my accuracies, you can notice that the highest accuracy I have received with the support vector machines, support vector classifier, right? So that's more reliable. You can even notice the standard deviation, it's small, which is the variation is very, very small with support vector machine. Right. Now that we have saved everything under the results, we can use to make a graphical representation. There are a couple of questions. Yes, there were a question, if you run multiple times, different accuracies are there because we have not controlled the accuracies. So if you want to get the same accuracies in every time when you run, you have to control the randomness, right? Right now, where is the problem? Only in the decision trees, right? Can you confirm? The randomness, what we are getting in the accuracies is only with the decision tree, right? It is because, you know, there's a randomness in the decision tree in model building. So you can fix it, right? I can say random state, maybe 1, okay, whatever the value. Now it will be fixed. Now every time when you run it, you'll get the same. Can you notice now? No changes, right? So hope that is clear to you, and I'll come to that point later on again. So that was one question. The other one, okay, actually Dylan has pointed out, thanks Dylan, yes, exactly. There was another question, finite modeling, which I will discuss later on because there are different classifiers we have to use, and maybe more advanced classifiers in deep learning might be useful for financial modeling. What we have discussed so far is classical machine learning, which might not, suitable when you need like high precision in your model building. Anyway, so what I'm explaining, I'm trying to explaining the use of graphical representation with the results. So that right now we can actually draw a graph. So let me take this one. So we can use import matplotlib.pyplot as plt, and then we can say plt.boxplot, or you can say plot kind box, and then we can say results. So should be able to get it. Yes, we are getting it. Maybe we can put the labels. So what I can do is I can set the title, algorithm comparison, right? plt.x label. We have not except I want to put the labels. Oh, okay, not in X label. This is just one, right? So I want to say xtick labels. Yes. Is it set? X. Okay. Okay, so I had to slightly update this one. I'm going to use the other way, which we will get the figure and axis label, because I want to have a more control of the outcome. So I'm going to use subplots here. This is the same thing, but you have a separate control over this one. So plot, it's the same, but here I'm going to slightly change. I'm going to use set title. Once you separate out, you have to do, okay, so this is what I want to do. Set xtick label, xtick labels, yes. And I'm going to use names. Y labels, we say accuracy, and then we will say, right. Okay, let me explain what I did, and then I will show you the code as well. So in plotting, actually, if you look at plotting, we normally use this fashion, although I have used plt.plot in previous one. So you have more control over when you use subplot command. So that's what I have done. And especially here, you will notice that in my graph, let me run again. Let me open up this file and explain. Right, okay. So here, so for example, instead of just one label, I have put xtick labels. So I put all the classifier names. So you can notice as a box plot, you see the accuracies. Since I have explained this one, you can see 50% of the accuracies will be here within, this is the average accuracy for decision tree, that is about like 70%. And you have more variance here, right? Similar here as well. Support vector machine as well, which is what you have taken. Yes. Is it what we are getting? Yeah, I have to check that one. But anyway, the idea is I'm actually trying to plot. I'm actually trying to plot the 4 classifiers that we have selected here, right? And then with the box plot, you can graphically compare the accuracies.